Welcome to AI Frontiers. Today's episode, Breakthroughs in Robotics Research October 2025, explores the latest advances in artificial intelligence and robotics. We will highlight cutting-edge findings from 35 new papers, focusing on perception, planning, and control. This journey brings you insights from the cs.RO robotics community, culminating in a deep dive into a standout paper of the day. Join us as we travel to the frontiers of intelligent machines. Autonomous vehicles must react in fractions of a second to avoid accidents. Remarkably, emergency braking distance at highway speeds can be reduced by more than 13 feet simply by improving robotic software. The difference between a minor incident and a major collision often comes down to the ingenuity behind robotics algorithms. Researchers' advances in milliseconds directly impact real-world safety. In this episode, we uncover the breakthroughs powering these life-saving improvements. Robotics is undergoing a pivotal transformation. No longer confined to laboratories, robots are entering daily life, our homes, streets, and workplaces. This episode examines 35 new papers that illuminate the next steps for AI-powered machines. We interpret the latest insights from the cs.RO field, uncovering researcher motivations and societal implications. The goal is to make robotics breakthroughs accessible to all listeners, regardless of background. The field of robotics can be imagined as a thriving city, constantly expanding and evolving. It is a synthesis of mechanical engineering, computer science, artificial intelligence, neuroscience, and additional disciplines. Within this city, perception functions as the sensory network, like urban cameras and sensors, enabling robots to sense their environment. Planning serves as the city's traffic management, optimizing routes and decisions. Control acts as the traffic lights, ensuring smooth execution of actions. Together, these pillars enable robotics to adapt to new domains and solve real-world challenges. A key theme in robotics is learning for control and manipulation. Robots learn not only through reinforcement learning, trial and error where actions are rewarded, but also through imitation learning, where they emulate expert demonstrations. Data-driven methods enable robots to generalize their skills to new tasks. Notably, approaches such as Phys2Real and ManyAgent integrate simulation, vision, and language to transfer skills from virtual to real settings. Imagine a robot chef improvising with unfamiliar tools, rather than merely following explicit instructions. This captures the essence of adaptive robotic learning. Robust perception and state estimation are essential for robots operating in unpredictable environments. Robots require reliable GPS and sensory systems to navigate noisy, dynamic worlds. New methodologies calibrate sensor noise and adjust to changing conditions, while adaptive heading estimation allows drones to function in environments with magnetic disturbances. This challenge is akin to driving through dense fog with unreliable navigation. Robots must combine creativity with technical rigor. The technical core is state estimation, determining where am I, by integrating diverse, often noisy, data sources. Autonomous navigation and planning in complex spaces represent another major research focus. Robots must traverse crowded streets, active factories, and disaster-stricken zones, often making rapid decisions with little margin for error. Systems such as Intersect-NDE, ADAPT-RPF, and GRIP advance dynamic route planning, enabling robots to reroute and circumvent obstacles in real time. The process is comparable to an air traffic controller managing shifting priorities. Advanced planning frameworks now decompose journeys into manageable, interpretable steps, increasing both robustness and explainability. Recent breakthroughs are best illustrated through specific research stories. Phys2Real, developed by Wang and colleagues, enables robots to combine prior knowledge with real-time learning to complete complex manipulation tasks. Navigate, by Lee and collaborators, allows bipedal robots to recover from slips using a fusion of planned behaviors and reinforcement learning. The sensor and memory approach by Kim et al. dramatically reduces data processing time in autonomous vehicles, enhancing safety. DemoHLM from Zhao and team shows humanoids mastering complex tasks from a single demonstration. Grip, introduced by Singh and Associates, offers a modular and explainable navigation system similar to a GPS that provides justifications for every turn. The featured paper Phys2Real by Wang and colleagues addresses the foundational challenge. Skills learned in simulation frequently fail when transferred to unpredictable real-world environments. Phys2Real overcomes this limitation by merging vision-language model priors with interactive online adaptation. The system intelligently combines what the robot knows from large-scale data with what it learns through physical interaction. This approach is analogous to a child adjusting to a new playground, relying both on memory and immediate feedback. Uncertainty-aware learning ensures that adaptation focuses on the most critical aspects of each task. Phys2Real's technical blueprint comprises three primary components. First, high-fidelity three-dimensional object models are constructed using 3D Gaussian splatting. Second, vision-language models estimate physical properties of objects, such as mass distribution, by analyzing visual and semantic cues. Third, these estimates are refined in real time through the robot's own interactions, with a focus on quantifying and reducing uncertainty. The outcome is perfect or near-perfect performance in challenging manipulation tasks, enabling robots to quickly adapt to novel environments and objects. Phys2Real represents a significant advance toward practical real-world robotics. By integrating prior knowledge with real-time adaptation, robots achieve robustness and flexibility that surpass previous methods. This framework reduces the need for extensive real-world training and empowers robots to explain their actions and rapidly adjust to unforeseen conditions. Such progress brings the vision of helpful robots in homes and industries closer to reality, setting new standards for adaptability and reliability. The future trajectory of robotics research resembles an exploration of uncharted wilderness. Foundation models, large neural networks trained on multimodal data, are expected to provide robots with deeper semantic understanding of their environments. Planning frameworks that account for risk and uncertainty will enhance safety and robustness. Lifelong learning will enable robots to adapt continuously, much like hikers navigating new trails. Advances in explainability are essential for building trust, transforming robots from opaque black boxes into transparent partners. Nevertheless, challenges persist, such as handling rare scenarios and achieving nuanced social intelligence. In summary, advances in learning, perception, and planning are revolutionizing the capabilities of robots. Research such as Phys2Real and Navigate establishes new benchmarks for adaptability. The ongoing evolution of robotics is shaped not only by expert contributions, but also by the curiosity and engagement of a broader community. Listeners are encouraged to explore these research papers, participate in discussions, and envision the next wave of technological progress. The journey continues as robots become integral to homes, streets, and workplaces. This episode's synthesis was powered by GPT 4.1 for narrative construction and summarization. TTS narration was generated with OpenAI technology, while visuals were suggested using Google image generation tools. All content was reviewed by human experts to ensure clarity and accuracy, though some oversights may remain. Complete references are provided for transparency. This collaborative effort between AI and human expertise brings curated, insightful research reviews to the AI Frontiers audience. Subscribe to AI Frontiers to stay informed about the latest breakthroughs in artificial intelligence and robotics. Engage with our community by watching, commenting, and sharing your insights. The channel features research deep dives and expert interviews for all levels of interest. Your curiosity drives innovation. Join us as we explore the evolving frontier. In this podcast, we bring you the latest breakthroughs in computer science and AI. Straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.